Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 16 physics series, where I am trying to help you to achieve your dream of getting 60 out of 60 in physics. Okay, so as you know, we are currently going through all the chapters of your first PU. We have already completed the chapter for work energy power, and now we are going to do the previous year questions from this chapter. And if you have not yet joined our WhatsApp channel, don't forget to join our WhatsApp channel. The link is given in the description. From there you can download our weekend KPL program, where we are going to give you questions based on your previous year KCET questions, pattern questions. Okay, so if you are preparing for KCET 2025 exam, then it is a must for you, and it is absolutely free of cost. You can join anytime. Okay, we have already completed 10 tests. Okay, this week there will be 11th test. I will give you the syllabus maybe tomorrow or day after tomorrow. Before that, let me continue with today's topic, that is work energy power previous year questions. So let's start with the first question. A ball of mass 0.2 kg is thrown vertically down from a height of 10 meters. Okay, so a ball of mass 2 kg is dropped thrown vertically down from a height. So thrown vertically down means it not only has some potential energy due to its height. Okay, suppose this is the height from the ground, then it does not only have the potential energy, that is mgh, it will also have a velocity. So it will have a kinetic energy as well as a potential energy. Thrown means it is thrown, it is not dropped. Dropped and thrown are different. Okay, so vertically down from a height of 10 meters. So height is equals to 10 meters. So it is 10 meters given. Okay, it collides with the floor. So upon collision, when it collides with the floor, 50% of its energy, it loses 50% of the energy. So 50% of the energy is lost. So what is the meaning of 50% of the energy? 50% of energy means it loses the energy which is 1 by 2 or 0.5. Okay, so it loses 0.5 times its energy. So initially, suppose it started with an energy say k, then after collision its new energy will be half k. Okay, because it lost 50% of the energy. 50% loss means it is becoming half. Okay, reduced by half. So 50% of its energy, and then rises back to the value of its same height. So after collision, even after losing the 50% energy, it goes back to the same height. Okay, now at this point of time it does not have any velocity. Okay, so initially when you throw it, it has some velocity as well as potential energy, right? But after collision, after it rebounds, it loses 50% of its energy, and then it reaches to the same height. So now it has only the potential energy, that is mgh, right? So the initial velocity that you have to find, right? The initial velocity is, so suppose the initial velocity is v. Okay, what is the initial energy? Initial energy is mgh, obviously we know that, potential energy. And what is the kinetic energy? Kinetic energy is half mv square. So this is the first initial energy, and just before collision, according to the conservation of energy, the same energy will be there just before hitting the ground, right? So just before hitting the ground, same energy should be there. Now what will happen is, just after collision 50% of this energy will be lost. So 50% of this energy will be lost, that means the remaining energy will be other 50%, right? So half of the energy is lost, half of the energy will still be there. So what is that half? So that is half mgh plus half mv square. Now after the collision, having this much energy, it rose to the height of h again. So this should be equals to mgh. This is the physics here. Okay, so whatever energy, after losing the energy, the whatever energy it has, that energy is sufficient to take it back to the same height, right? Now this is the equation. From here you can see that m is common in all the terms, so you can take m common here as well, and you can cancel that, right? M will be common and you can take it outside, right, and you can cancel that. So, after cancelling the M, you can do the cross multiplication. You can write GH plus half V square equals to 2GH, right. So, these 2 will be gone here as a multiplier. So, it will be 2GH. So, half V square equals to 2GH minus GH equals to GH, right. So, V equals to square root of 2GH. So, this is the case in the given case. This is not a general case, this is a particular case only. For problem similar like this, you can use this formula. This is not a general formula. So, V equals to what is 2, G is 10, height is given 10 meters. So, we can see that it will be 10 root 2, right. In the option nowhere nothing is given. So, what should we do? So, we have to break root 2. Root 2 is 1.414 or it will be 14.14 meter per second velocity. So, meter per second is the unit, and as you can see from the given option, 14 is the correct answer. So, correct answer is option A, 14. Okay. Now, let us move on to the next question. A smooth chain of length 2 meter is kept on a table such that its length of 60 centimeter hangs freely from the edge of the table. So, there is a table there, okay, and from that table, okay, 60 centimeter. What is the total length of the chain? Let me draw the chain first, that will be easier. Okay, this is the chain, and from the entire chain some part is hanging. Okay, this is the table. Okay, this is the table. Now, from that table, obviously it is hanging, 60 centimeter hangs freely from the edge. So, from the edge whatever is hanging, this is 60 centimeter, right. The total mass of the chain is 4 kg. So, total mass of the chain is 4 kg. The work done in pulling the entire chain on the table is. So, what we have to do? We have to pull the entire table, entire chain into the table. So, we have to calculate the work done. So, what is that? If we pull this chain in this direction, what is the total work done in pulling? Now, this requires certain element of center of mass concept, which I have not done during our KCET revision, but I hope you have done that chapter in your first PU and have the knowledge of center of mass, that you can consider the entire mass of this chain is actually half located at a half distance. For an uniform object, okay, if the object is uniform, the center of mass can be considered located at the midpoint, right. That is the concept. For a cubical cube, it will be the center of the cube. For triangle, there are 2 different points, center of gravity and center of mass. Okay, there are little complicated, but for normal regular objects, it is at the midpoint. So, the chain we can consider it to be a regular object, and we can say that the center of mass is located here. So, we can consider, if we can find the mass of the chain, okay, this 60 centimeter length of the chain, then we can say that instead of having the entire chain, we can consider that only half of it is located, here only, right. So, we can say that, let me use a different color, let me use white color. So, we can say that a mass of having the entire mass of the chain is located exactly at the midpoint, and we are pulling this object upwards. Whatever work we have to do, that is the work done, right. So, that will be the work done. So, what is the mass of this? First of all, we have to find the mass of this piece. Okay. Second of all, what is the height? Height, you can see this height will be, if this is 60 centimeter, then this should be 30 centimeter, right. Half of 60 is 30 centimeter. Okay. So, now what is the mass? Mass of the entire chain, that is mass of 2 meters, right. 2 meter means 200 centimeter. Mass of 200 centimeter is 4 kg, So mass of 200 centimeter is 4 kg. So mass of 60 centimeter should be 4 by 200 times 60. This is the mass of the this much wire, this much chain, right? So it will be 5. So as you can see, it will be 6 by 5 kg. 6 by 5 kg is the mass of the chain, and where it is located? It is located here, right? So it is located 30 centimeter below the table. So how much work you have to do? What is the potential energy of this object? There is no other energy, kinetic energy is not involved because it is at static condition. So you have to calculate the potential energy, and then that's it. That potential energy you have to put to bring it back upwards. So what is the potential energy at this point? Potential energy is given by potential energy, actually it will be negative, but I am not considering it to be negative. It will be simply mgh, right? So what is m? M we have calculated 6 by 5, g is 10, and h is 30 centimeter. Now 30 centimeter means 30 divided by 100 meters. You have to convert it to meters because in SI unit, meters is the unit of length. 0 0 cancels, this 0 cancels. Okay, so you can see this will be 18 by 5 joules, or 18 by 5 means 3.6 joules. How did I do it? You multiply with 2 top and bottom, so it will be 36 and divided by 10. 36 by 10 means 3.6, right? So now let's look into this question. Calculate the work done when a force F equals to 2I cap plus 3J cap minus 5K cap units acts on a body producing a displacement S equals to 2I cap plus 4J cap plus 3K cap. Very easy question. How to solve it? We know that work done is nothing but W is equal to F dot S dot product. So we basically have to find the dot product of these two given vectors. So I am not writing the vectors here. What I will do, I will teach you how to do the dot product once more. So first of all, we have to check what is the I cap components. So I cap is 2 here, here is also 2. So basically it is 2 into 2, that is 4. Okay, plus or minus whatever sign you will get, but I am writing plus. I will add the sign later if required. Now next is plus 3j plus 4j. Okay, now we are moving to j components. Okay, so 3 times 4 is 12, so it will be plus 12, right? Next is I am writing plus as usual. So minus 5 plus 3, minus 5 plus 3. Now we are taking the k components. So minus 5 plus 3 is minus 15, so it will be minus 15. So basically it will be 16 minus 15, so it will be minus 1. Plus 1 joules. 16 minus 15 is plus 1. So 1 units. Whatever joules, I used SI units, so I thought it may be joules, but they have not mentioned any units. So you have to write in terms of units only, right? Now let's move on. Question number 4. A ball hits the floor and rebounds after an inelastic collision. In this case, so you take a ball and you hit it on the floor, and the collision is inelastic. Inelastic means the energy does not conserve, right? So momentum of the ball is conserved. Obviously the momentum is always conserved, does not matter. Okay, energy will not be conserved, mechanical energy will not be conserved. Okay, the total momentum of the ball and the earth is conserved. So earth's momentum is not conserved. Okay, you cannot consider earth momentum. In this case, earth will not be changing its direction. Okay, so earth's momentum will still remain 0. Okay, the total mechanical energy of the ball and the earth is conserved. No, total mechanical energy will not be conserved. Okay, only momentum of the ball is conserved, right? You remember that momentum will be always conserved. A body is initially at rest. It undergoes one-dimensional motion with constant acceleration. The power delivered to it at time t is proportional to. So a body is initially at rest. So body initially at rest, it undergoes one-dimensional motion with a constant acceleration. So acceleration is constant. So you have to find the power delivered. What is power delivered? The formula for power is force times velocity. If you remember, formula for power is force times velocity, right? What is velocity? Velocity is u plus at, right? Now in this case initially at rest, so u equals to 0, so v equals to at. Now remember that acceleration is constant, given here acceleration is constant. Now what is force? Force is equals to ma, right? And v we have calculated is at, right? So it will be m a square t. Now remember that mass of the object is constant, it is not changing, acceleration is constant, it is not changing, and it is only dependent on t. So p is proportional to t. So correct answer is option D. Okay. So this is one of the cases where we found that the correct option is option D, not option A, B, C. Most cases in KCET generally we see options are generally located in A, B and C, but some rare cases option D is also correct. Now, during inelastic collision between two objects, which of the following quantity always remains constant? Same question again. Total linear momentum, total kinetic energy, speed of each body, total mechanical energy, total linear momentum is always conserved. Okay. Now, two particles of masses m1 and m2 have equal kinetic energies. The ratio of their momentum is very interesting questions. So kinetic energy is same. So two objects, object 1 suppose mass is m1 given and object 2 mass is m2. Okay, its momentum is given by square root of 2m1 kinetic energy E. Both of them has same kinetic energy. Its momentum will be given by P2 equals to square root of 2m2 E. I have discussed this formula in our class, if you remember. So this is the basic formula that you have to remember to relate kinetic energy and momentum. Based on this formula, a lot of question comes. So you have to be careful about this formula. Now they have asked you to find the ratio of their momentum. So basically what you have to do, you have to find P1 by P2. P1 is square root of 2m1 E divided by square root of 2m2 E. So now E and 2 are constant, so they will cancel. So it will be square root of m1 divided by square root of m2. So basically answer will be m1, square root of m1 is to square root of m2. So this is the correct answer, right? Now next move on. A motor pump lifts 6 tons. Okay, it is not ton, it is tons. Okay, tons means you have to remember that 1 ton T-double-N-E is equal to 1000 kg. Okay, this is the thing. 1 ton ton means 100. Okay, so ton ton is very common in cricket. If you watch cricket, okay, he has hit a ton, that means he scored a century, right? So ton ton is 100, T-double-N-E, that is T-O-double-N-E, that represents 1000. Okay, so a motor pump lifts 6 tons of water from a well of depth 25 meter to the first floor of height 35 meter from the ground floor in 20 minutes. The power of the pump. Now here the construction is very important. So 25 meters under the ground till 35 meters above the ground, right? So this is the first floor. From here 25 meters below and 35 meters up. So here is the tanker, here is the storage where you store the water. There is a pump located here, it is taking water from here and it is pumping to the storage, right? So this is your pump, this is 35 meters. Now what is the total height? What is the total height? Total height, as you know, it should be addition of these two heights. So total heights will be 35 plus 25, that is 60 meters. Okay. So the pump is basically pumping the water up to a height, total height of 60 meters, effective height of 60 meters. So what is the potential energy of the water that is being pumped here? So the potential energy, we know that is basically mgh, right? And what is m? M is given 6 tons. 6 tons means 6 times 1000 kilograms, g is 10 and h is 60. This is the energy. Now basically this is the work done also, right? So whatever is the potential energy change, that much energy should be work done as well. Now if this is the work done, then what is the power? Power is nothing but work divided by time. How much time it took to do this work? 20 minutes given in the question. So 6 times 1000 times 10 times 60, okay, divided by 20 minutes. 20 minutes means 20 times 60 seconds, right? You have to convert it into seconds. So 60 cancels. Let me cancel this 0. So 10 is gone, and let me cancel 3 to the 6. So what is left is 3000. 3000 watts. 3000 watts can be written as 3 kilowatts, right? So the correct answer is 3 kilowatts. Answer should be in kilowatts, right? So this is the answer. Now let's move on to the next question. A 12 kg bomb at rest explodes into two pieces of 4 kg and 8 kg. So there was a bomb, okay. So the bomb explodes into two pieces. One piece goes this side, say with 4 kg. Another bomb goes to this side. It is moving this side. This is moving this side. This is 8 kg, right? Now what will be conserved in this case? The initial momentum of the ball, initial momentum of the bomb is 0, right? So initial momentum will be 0. So final momentum will also be 0 because momentum is always conserved. Suppose this ball is moving with the momentum P1 in this direction, then the other piece should move with the momentum minus P1 on the other side, right? So basically the magnitude of the momentum should be same for both the balls, even though the velocity will be different because they have different masses, but the momentum should remain same, right? Because P1 plus P2 should be equals to 0. So P2 is nothing but minus P1, right? So now it is given that in the question, if the momentum of the 4 kg piece is 20 Newton per second. So the momentum of the 20 kg piece is given 20 Newton second. Okay. So what will be the momentum of 8 kg piece? It will also be 20 Newton second, opposite direction, but magnitude will remain same, right? So the momentum of this 8 kg piece we have calculated directly without using any maths, right? The kinetic energy of the 8 kg piece. So they have asked you to find the kinetic energy of the 8 kg piece. There are two different ways. The easiest way is to use the formula that P is equal to square root of 2me or Ek. I am writing kinetic energy, so Ek. So Ek is basically equals to P square divided by 2m. If you remember this formula, it will be very helpful for you to solve such questions. So here P is 20, so 20 square, okay, and mass is 8 kg, so it will be this. So 20 square is 400 divided by 16, okay, so it will be 52 or it will be 25 joules, right? 25 joules is the answer. Now let's move on to the question number 10. The kinetic energy of a body of mass 4 kg and momentum 6 Newton will be. Another similar question. So they have asked you to find the kinetic energy. We have already used the formula in our previous question, P square by 2m. Okay, P is given 6. So 6 square divided by 2 times 4. So if you see, there are few pattern questions coming every year. So 36 divided by 8, okay, so 9 by 2 or 4.5 joules. So 4.5 joules, okay. Now a force of 10 Newton displaces an object by 10 meters. If the work done is 50 joules, then the angle made by the direction of force with the direction of displacement is. So what is that? We know that work done is nothing but Fs cos theta. There is a dot product, right? So in case we know that angle, we can use this formula Fs cos theta. So here the work done is given by 50 joules. So basically we just need to construct the equation and solve the theta. So force is 10 newtons and displacement of the object is 10 meters, right, cos theta. So what is cos theta? Cos theta is 50 divided by 10 times 10, that is 100. So it will be 1 by 2, right. So theta is nothing but 60 degrees. Cos 60 is half. So answer is 60 degrees. 12. A falling body strikes the floor with the speed of 2 meter per second and rebounds with the speed of 1 meter per second. Okay. So the loss of the kinetic energy, loss of the energy. So basically, if you have a ball, if you drop it, okay, after hitting the ground, it loses some of the energy and it rebounds a little less, right. So here they have said that just before touching the ground, the speed was 2 meter per second, and just after the rebound, just after it hits the ground, its speed decreases to 1 meter per second. Now what you have to do, you have to find the change in the energy in percentage form. So how can we do that? If we know what is the initial kinetic energy, if we know the initial kinetic energy EKI, and if we can calculate the final kinetic energy EKF, and then if you divide this by EKI, okay, and then multiply this entire thing with 100, then we can say this is the change in the percentage energy. This is the formula, right? Initial minus final divided by initial. For any quantity to calculate the change in percentage, okay, that is the formula. Now what is initial kinetic energy? Initial kinetic energy EKI is half m v1 square, and what is final kinetic energy EKF equals to half m v2 square. Okay. So as you can see, you can take half m as common. So half m will be common, right. In here we are writing v1 square minus v2 square divided by, if you write it in terms of formula without calculating from the beginning, it saves some mathematics, especially in cases where complicated values are given. Okay, so don't just calculate. I could have calculated E1 and E2 directly and put those values, but it will be little bit complicated in terms of calculations. If you do this kind of approximations and little bit put the values at the last time, then it will solve a lot of your questions faster. Okay, so v1 is 2 square, so initial speed is 2, so 2 square, final speed is 1, so 1 square divided by v1 square is 2 square times 100%. Okay, what is 4 square is 4 square, 2 square is 4, 4 minus 1 divided by 4 times 100%. So 3 by 4 times 100%, that is 75%. 75% of the energy is lost. Okay. Now next question, two bodies of masses m and 4m are moving with equal kinetic energy. The ratio of their linear momentum is. So we know that it's same question we have solved before as well. P1 equals to square root of 2me, right, and P2 is 2 4m E. Both has the same kinetic energy, but mass is different, so momentum will be different. So P1 divided by P2 equals to everything will be cancelled. As you can see, only thing that will remain is 1 divided by square root of 4. Rest 2 m e, everything is common, so they will cancel. Only this 4 will remain and this square root will remain, so it will be 1 by 2. Okay, this is the quickest way to solve such questions. Don't need to write everything in detail. Okay, as long as you are understanding the problem and you are doing it properly, you can answer them with some steps you can skip. Okay, now this is an interesting question. Now remember that all the questions that we are solving are not exactly part of the PYQs. Some of the questions were deleted, so I have included some pattern questions from reference books. Okay, so if you want to only PYQs, you can check the PYQ books available with you, but there some of the questions are deleted, so it will be confusing for you which questions are deleted, which questions are not deleted. So better follow this class and download the notes when available, so that you can understand and you can practice these questions, right. So now question number 14, the relationship between the force and the position x of a body is as shown in the figure. The work done in displacing the body from x equals to 1 meter to x equals to 5 meter is. So what is the work done for moving the object from here till here? Okay. So we know that the work done is basically for fx graph, area under the graph represents the work done. Okay, if it is in the positive side, then it is positive work. If it is downward side, then it is a negative work, and work done has sign. We have to use the proper sign. What is the work done here? What is the area? Basically work done is nothing but the area. Okay, so we have to calculate the area along with their sign. So what is the area of this? This is a triangle, right? Triangle's area is half base times height. What is base here? Base, as you can see, it is 0 to 1, that base is 1. And what is height? Height, you can see this is 0 to 10, so height is 10. Plus, now what is the area of this rectangle? Next is this, right, in line. We have to calculate everything individually. So this has a height of 10 and length of 1, right. For rectangle, its length times breadth. So breadth you can consider this 1 and length you can consider this 10. So it will be 10 times 2, sorry 1. Next is this smaller rectangle. This is also positive, right? This is also positive. This has breadth of 1 and length of 5. So it will be 5. You can write them like this, so you don't get confused. 5 times 1. Okay. Next one is below, right. So below means it is negative sign, and it has same as this 5 times 1. So it is minus 5 times 1. Okay. And then another triangle again upwards. Okay. So it will be again half of 1 times 10, right. 1, 5, 4 to 5, 1 and then 10, right. So let's calculate now. So it will be 5, this will be 10, this will be plus 5, this will be minus 5, so they will cancel, and then again another 5. So it will be 20 joules. 20 joules is the answer, correct answer. Okay, sometimes students forget that, or even they think that work done is a scalar, so we don't need to consider the sign. No, you have to consider the sign, because work done can be positive, work done can be negative, work done can be 0. So if the one case work is positive, in another case work is negative, then you have to add them such a way that you get the net work done, right. Now let's move on to the last question of today's lecture. When a bob of a simple pendulum swings, the work done by the tension of the string is. So a bob of the tension simple pendulum swings, it swings in this direction, right. So what is the direction? Direction is of displacement is along the tangent, and the tension is along this direction. So what is the angle between them? Angle between them is 90 degrees. So if the angle between the force and displacement is 90 degrees, then what do we call it? We call it no work force, right. So basically this is a no work force. So the work done will be equals to 0, right. It is not greater than 0, not less than 0, it is not maximum, obviously. Okay, you can check the options. It is a very easy question to guess. Even if you want to guess, easy to guess that it will be equals to 0, because less other options does not make any sense, right. So I hope you enjoyed today's session. I will be back with system of particles and rotational motion tomorrow, and also all the videos that we are doing is available in the playlist. Okay, you can check out the playlist, and also if you want to participate in KPL, or you want to get any notification related to KCET 2025, any information that is coming from KEA or any other information that we can collect will be provided in our WhatsApp channel. For that you have to join our WhatsApp channel, link is given in the description, and I will be back with the new video. Till then, bye, and don't forget to subscribe to our channel if you have not done yet.